Welcome everybody to Index webinar number 7, the importance of terminations. What is a ferrule? My name is Michael Merrington. I'm the general manager of Index. We are Hazardous area EX professionals. We wanted to share our experiences from all viewpoints, from all stakeholders, from manufacturers, EPCs, end users, the technicians, inspectors, and engineers as well. I'm going to turn off my camera now so that you guys can concentrate on the presentation. Okay, so why the focus on terminals and terminations? Well, it's mentioned in the standards quite a few times that ends shall be protected against separation of cable strands. Example, by means of cable lugs or core end sleeves. Creepage and clearance distances are mentioned. Unused cores are mentioned. So the importance of terminations is to stop line-to-line shorts, line-to-ground fault, to not cause explosions by not having arcs, sparks, and hot points. So 80% of all our non-conformancies in our industry, approximately, are glanding and terminations. Now, to separate those two is very difficult because usually the faults go together. When the glander has had problems and there's punch list things that need to be punch listed, usually it's the same for terminations. So common issues: stranded conductors, fraying, terminals too loose or too tight, reduced creepage and clearance distances, use of incorrect termination means, quality connections, which lead to loose connections, increased resistance, and the potential source of ignition. Increased heat, temperature rise, not good for hazardous areas. Not following the order of precedence. When you're installing a terminal and your end sleeves or whatever you may use, you have to follow the certificate of the terminal, the manufacturer's installation operation maintenance manuals, and the pertaining standard to the EX protection type. Now, the client end user specification shall meet or exceed these requirements. If not, I highly suggest owner's engineering review on behalf of the end user, perhaps by a third party. Now, here's an example of EXM connections. Now, this is a modular bus duct that can go all the way up to 17.5 kV, 17,500 volts. These are used as a replacement of cables because it allows for higher current, higher voltage in a smaller space without the use of cables. It's a wonderful design, but you have to preserve it. What happened? The manufacturer's IOMs, installation, operation, and maintenance manuals, were not followed. So what was the manufacturer's recommendations? They said that it shall be cleaned and dry. If required, clean conductor ends, use a roughen pad, a brace of paper, roughen it up, and it shall be free from dust and humidity. Use a hot air blower. None of that was done on this connection. So what are the chances of failure for this joint in the future? Well, the joints have a cement type pouring done on each joint. Once it is done, it cannot be undone. So if you have a 1 kilometer run of this and you have a problem, you could be looking at millions and millions of dollars of ordering new equipment. You would have to take out this entire length of bus duct. Now, its terminations on the ends must go into another EX type of protection, say an EXE enclosure. So preservation was not done. The correct methods of dealing with it were not followed. And I would not be surprised if that water seeped into the encapsulating concrete or whatever type of compound it was. And we're dealing with tight tolerances, yeah, creepage and clearance distances on medium voltage, okay? It's a good product, was not preserved or installed correctly. Now, about transformers. Well, transformers have, if it's oil-filled transformer, its terminal boxes are usually EC, EB, EC, or NA. You might have pressurized, but you have to follow their instructions. Well, what happened on this one? There was unauthorized modifications. This was an ED, IB, MB, OB, so had intrinsically safe devices on it. MB, well, it had that bus duct going into it on the other side. O, oil was in the main compartment, and then you had these insulated bushings. So when we look at the top right-hand side, this is how it was done correctly. But unfortunately, the designers did not account for the 100 or 150 millimeters of ground subsidence. The structure was sinking. Now, the cable went straight down the cable tray into a conduit in concrete that went all the way over to a substation that was also on concrete, and there was no space under the substation. So you could not replace the cable. The after effect, I will not show that picture, but it was not pretty. But what they did do is, due to the subsidence, the stud was damaged. So the EPC came up with the idea to elongate, modify the lug holes to make it fit. But when they put it on, they bent it. So when they were too short, they then took an earth bar and cut it down. I don't believe an earth bar is meant for the fault current that a transformer is meant for. We were told that this was designed this way. So the designer, there's definitely issues with the installers, but the designer, what about ground subsidence? Why was it called to be installed straight? Can you all hear me? One gentleman said he cannot hear me. Okay, very good. Now, key points. D, E, P, I, O. You know, they all involve creepage and clearance distances. Yeah, we have to have segregation between lines, between line and earth, between IS and non-IS. Choose the correct terminals, type of ferrules, and the correct use of it. Also the correct tools, environmental considerations, life of the facility. Is it 10, 25, 35, 40, 40 plus years? What about stranded conductors? Stranded cores, distance to movement, resistance to heat and vibrations, unauthorized modifications, and once again, the documentation. Have they all been followed? Now, let's open up a poll question. Gentlemen. If we ask you the question, what are insulated pin crimps used for? So there's many different industries there. Multiple choice. Now, not what they're used for actually, but what are they rated for? 31% voted, so we'd like to get more. More people, the better, please. %. Once we get up to about 70%, I cannot select. Some people cannot select. Strange. Sorry, gentlemen, I do not have control over who cannot and who can select. Okay, we got 59, 60% voted. Just 1 second. Okay, and we'll close in 10 seconds. People say they can't vote, but we're up to 62. Apologies if you cannot vote. Okay, close. So we'll share that. Now, perhaps the understanding of insulated pin crimps, you'll find out in the next slide. Insulated pin crimps are primarily a commercial and marine use termination. We'll go over why. So, also another importance, correctness of stripping. Too short, getting insulation. So when we're mentioning insulated pin crimps, they are rated for marine and commercial, therefore also residential use. Now, also importance for stripping is if it's too long, your creepage and clearance distances are now too short. If you terminate on insulation, obviously you're damaging the insulation of the core, and you're obviously going to have high resistance. So, creepage and clearance distance, what is it? Well, your clearance is your air distance. Your creepage distance is your surface tracking distance. Now, within the standards, it clearly states in -14 for installation, in -7 for EXE, in -11 for intrinsically safe, -15 for EXNs, which have primarily been wiped out and moved to other protection techniques, in -0. So the importance of this is that terminations insert themselves all the way into the terminal. Diligently followed? No, because who gets this table in the field? No one. But if we're looking at EXEB for a group 2 for 1,000 volts, we're looking at 25 millimeters of minimum creepage distance, and clearance, we're looking at a minimum 14 millimeters. That's a big space. Now, sometimes people remember a 6 millimeter rule. 6 millimeter only applies at 250 volts, and that's 6.3 for creepage. Once you get up to 400 volt, you're at 10 millimeters. So trying to remember these tables is not practicable. So, creepage and clearance distances. Let's look at a real world installation. Right here, we have ferrules, nicely inserted, creepage and clearance distance is maintained. Now on these other ones where the insulated pin crimps are used, well, I can see metal exposed because the insulated pin crimp cannot insert into the terminal. Here's your issue. Insulated pin crimps, one of the issues with them is they do not sufficiently insert into a terminal. Now, let's just ask a question. Have you used ferrules, bootlace crimps, core end sleeves, all the same meaning? Yes or no? And you like them? Do you not like them? If no, would you like to use them? Hopefully more people can vote this time. That's okay if you can't vote. Apologies. I cannot control that one this time. Yeah, 52% have voted. Fortunately, I do not have control as to not vote, and I do not want to restart and lose all of you. We have 100 people this time. Okay, so I'll give another 10 seconds. If you can't vote, apologies. Okay, let's share. So overwhelmingly, we're looking at 77% like them, 11% have not used them but want to, 5% say they don't like them. Interesting. And 7% said yes, but they don't like them. I would like to know, perhaps in the feedback after the presentation, please tell me what you think is a better termination means. That is higher production, high quality, and produces less faults. Okay. So terminals, well, they're clearly defined. What types do we have? Many different types. You got many different types of manufacturers. You know, you got Wago, you got Wiedmuller, you have Phoenix, many different ones. My preference is terminals, not posts. Problem with posts is, well, they're exposed. So if it was intrinsically safe, somebody could short something out. They're not, it's not the safest, it's not the cleanest. It's kind of a quick, cheap junction. So with these terminals, we get good creepage and clearance distance. So see here between IS and non-IS, you have to get 50 millimeter separation. You can do it via spacing or a divider. And once again, if you have two levels, you do have to have 50 millimeters between both levels and between the singular level. So we have to do a calculation. It's highly important how many terminals we can use. The segregation between IS and non-IS, our creepage and clearance distances, our terminal type, our ferrule type, also standardization, perhaps EXEB terminals. So if a manufacturer or a vendor, EPC, always called for an EXEB terminal, well, they would have increased quality in their works, reduced reworks because they wouldn't be repeating, let's say, when you have the two types of terminals on the shelf, the person selecting it many times selects the wrong one. And as we do inspections, then you're going to have a lot of reworks. It raises the reputation of the company, and you have multiple options for your EXEB or IA, or protective earthing, functional earthing, or your intrinsically safe earthing. You can have dual layers on all of these. You can have knife switches. The options are there. Or you could just go with a post. But if you have regular terminals that are not EX and you put them in EXD, that is okay, but you have the chance of mixing your terminals up, your EX and non-EX. So you may put non-EX terminals into an EXE or EXNA box. That will be punch listed, and that will be a fault. Potential ignition source, yes? Now, when selecting the total number of terminals within your box, well, as per the standard, it's clearly defined based on the overall current, the size of the conductors, the size of the terminal's acceptance, and how many can be selected. So the standard tells you, and also the manufacturer tells you. Generally, the manufacturer does all the calculations. So you can order an EXE box, but they're going to ask you, what power usage are you going to have for in that box? Now, to go back to terminals, there's the difference between screwed and spring types. If I were to use this spring type here, I would only use a Ferrule. If it's a high quality terminal, I'm okay with those. This is just my personal preference. Screw type is my preference. What is the reason for people not liking Bootlace crimps? That'll come up. But the reason for not liking Ferrules, please definitely tell us at the end. Unused cores are found in all the standards. Somebody's asking about that. Look in 14, installations. Unused cores must always be terminated to a terminal and earthed back in the safe area, the non-hazardous area. So usually your LER, your substation. At the instrument end, you would have your shield drain floating, and you would not earth it at that end. Some people do, but it's not the greatest of ideas. Now, when we look at all the different types, when we look at a Ferrule or Bootlace crimp, well, when we do a Google search for Ferrule, that's what comes up. When we do a Google search for core end sleeve, well, Ferrules come up. When we do a search for insulated pin crimp, here's your insulated pin crimps. By the way, commercial grade. Cable lugs, industrial grade. Insulated ring lugs, commercial grade. Now, what are important considerations when selecting Ferrules and terminals? Hopefully more of you can vote now. Apologies if you can't. Multiple choice. Welcome back, those who have joined. Minimize and maximize window and back. Okay, let me try that, gentlemen. It'll have to be after the voting. 55% voted. I'll just share it now. Apologies if you can't vote. So 83% say creepage and clearance distances. Now, guys, the answer is all of them. It shall be 100% across the board. What are important considerations? Well, human factors. Is there a high chance for faults, like with insulated pin crimps? Is there problems with suitability for EX type, like insulated pin crimps? Is there problems with creepage and clearance distances, like with insulated pin crimps? Voltage, that's okay for insulated pin crimps. Cost, well, insulated pin crimps are cheaper. So if you guys didn't think cost was an issue, why do you continue to select insulated pin crimps? So if 80% of everything, the non-conformancies are terminations, and usually they're insulated pin crimps, but cost is not a factor for you, why do you select insulated pin crimps? Seems self-defeating. Now, I'm going to try minimizing and maximizing, guys. Can everybody see one screen right now? Can everybody see okay? Can anybody hear me? Okay, good. Now, why the use of ferrules? Well, see, this has been done by the manufacturers, yeah? This has been done by Wiedmuller, by Phoenix, okay? But why the use of ferrules? Well, greater design life. Reduced resistance equals less heat, less chance for ignition in a hazardous area. Less heat, once again, less potential ignition of gases, vapors, liquids, or dust. Also, they withstand vibrations and temperature swing. So when you look at a salty environment, the one on the right, well, the one with stranded wire with a ferrule lasts a long time. The one without a ferrule, a very short time. Now, the definition of ferrule has already been defined. It's not an insulated pin crimp that they used for this testing. By the way, after 5 years, the wires and everything moves every single day. Hot, cold, hot, cold. Metal expands and contracts. So your insulated pin crimps, well, you're still going to find more things coming up as to why they're not the greatest. Now, why do we use ferrules? Well, in the standard for -0, it says ferrule. Metal tube crimped over to secure it, has insulating protection. Any exposed portion of the wire are not completely inside the terminal post. So the insulation is not being crimped on and the metal is not exposed. I think we showed pictures of insulated pin crimps with metal exposed. Now, core end sleeves. It's just another word for crimp, core end sleeve. The creepage and clearance distance in accordance with protection technique shall not be reduced by the method with the conductors are connected to the terminals. Insulated pin crimps seem to do that. Endless evidence throughout the industry. 14, general requirements for installation. The ends shall be protected against separation of the strands, for example, by means of a cable lug or core end sleeve, or by any other type of terminal. Any other type of terminal. So it doesn't say any other type of termination. All it says is cable lugs and core end sleeves. I think we defined what those are. So when you go into -7 and -15, EXE and N, well, there's a lot of considerations there, which we're going to go through. So let's go with another poll. No, okay. So insulated pin crimps, why are they horrible? Again, it's not directed at any manufacturer, and usually it's not the likes of Wiedmuller, Wago, and all them that make these. So ferrules. Well, the insulated pin crimp has half the surface area when crimping. There's the pin crimp with its insulation removed. It's half the distance. So more resistance. When crimped, it is not circular or compact, as per the standard. There's also damage to the core insulation. As you can see on the black here, it is misshapen. Unfortunately, when you use these crimpers, it crimps on the metal and the insulation because it can't do any other way. So it damages the core insulation, it damages the crimp insulation. The individual strands are no longer circular and compact. It is misshapen. There is not a clear means of crimping it where it is 4-sided or 6-sided. It is a misshapen mess. It also fits poorly into terminals. We have evidence of that. Also, you can only use one core, not 4, like this one, like they did. This is my installation picture from a few years back, one that I was inspecting. Earths. Let's ask a question about earths. Do you use insulated ring lugs for earths, and do they break often? Yes or no? %45 voted. Apologies for those who perhaps cannot vote. Can you vote now? So minimize the screen. Hopefully that solves things for you gentlemen and ladies. Can you vote now? Give it a try. Okay. Apologies. Users need to minimize the screen. So if you minimize your screen and then maximize again, you should be able to do it. So, do you use insulated ring lugs? Bit of a contentious poll. I didn't give it enough options, but I would hope that the no is 63% no, as in we don't use them. But this 37% that say they do use them, they do realize they break. To give people without the field experience, or let's say on an existing asset, they break all the time. Why? They're a commercial grade product. They're used because they're cheap. On good sites with high quality, yeah, where they're thinking of 40-year design life, we use the all metal lugs, and we use a heat shrink over the crimped section. And the reason for that, your earthing is your most important system. Without earthing, there's a chance for personnel and equipment to be fried. So that can be interpreted in many ways. Now, now, why are insulated pin crimps no good according to the standards? Well, -7 and -15 clearly call it out. And I can show you in my side-by-side comparisons for you that I did the other day. Cannot slip out of the intended location during tightening. Well, in the terminal for Ferrule, it has a sloped collar. It will not be crimped on. The problem with the insulated pin crimp is it cannot always get all the way into the terminal. Avoid loosening of the connection during service. Well, you have a square flat surface on the pin crimp, or on the ferrule, or 6-sided, while you have a round surface on the pin crimp without damage to the conductors. Well, the conductors are misshapen. On a pin crimp, you have no idea how far your individual strands have been picked up. If they are too short, you can see through a window sometimes, but sometimes you are crimping onto the insulation of the core. within the metal, but also you definitely are crimping on the insulation, unlike a ferrule. Does not be impacted by temperature changes. Well, there's more surface area on a ferrule. Yeah, vibrations, temperature changes, it has more surface areas to remain at. Yeah. Provide contact pressure that does not depend on the structural integrity of the insulating materials. Well, the pin crimp, the insulation has a lot, that collar acts as a means of keeping that core from moving around too much. So once again, it doesn't meet the standard. Not be specified to accommodate more than one wire, and if it does, allow it to do so. Dual bootlace, the dual wire ferrules allow for that. The insulated pin crimps do not. If intended for stranded conductors, protect the conductors and distribute the contact pressure evenly. Well, see a square, hexagonal, for ferrules, contact pressure. Insulated pin crimps is not even contact pressure. Now, somebody said that terminating is to be done by qualified people. Unfortunately, many people in the industry are not qualified. Let me put it this way. Qualifications are only 15%, or maybe 30% of competency. Competency is skills, knowledge, and experience. If you're expecting your quality management system to rely on the humans, on the hierarchy of control, you are relying on administration and PPE, when you could rely on engineering and substitution. You can use a higher quality product, which has less chance for human factor issues. So you can fight the industry, or you can be more efficient and stop fighting and make your life easier. Once again, in the standard, it clearly calls for ferrules or core end sleeves. Every single line by line here, reliably forming the stranded conductor into effective shape that does not subsequently change in service. It accommodates any settlement. Once again, it's misshapen and not perfectly formed in insulated pin crimp. Have torque values specified by the manufacturer. Both of them have that if you use a proper crimper. But for screwless connections for fine strand wires, conductors shall be equipped with a ferrule, or a termination shall be made to open the clamping mechanism so that the conductor does not are not damaged during the installation of the conductor. Well, by using it in insulated pin crimp, you are damaging the conductor and the insulation of the conductor and the insulation of the pin crimp. Good for commercial, no doubt about it. I'm not ragging on it. But when you compare it directly to the standard, it does not comply. It is not a ferrule. Now, can EX enclosure use ferrule without the insulated bootlace? Yeah, you can still use a ferrule that doesn't have the insulated collar, but highly suggested because you guarantee your creepage and clearance distances. Now, I already showed you the examples of, there you go, it doesn't, look at the ferrule, it goes all the way into the terminal, while the insulated pin crimp, you're struggling to get it in and usually does not get all the way in correctly because it's not designed for EX. It is not designed for reduced creepage and clearance distances. It's designed for commercial and marine applications. Once again, creepage and clearance distances, quality. Now, how easy is it with a ferrule? Well, strip it, twist it, slide it on, crimp it. I can install these in 1/3 the time of an insulated pin crimp. So anybody that says it's about cost, well, man hours cost a lot more than 1,000 little pin crimps. Once again, here's a 16 millimeter, and it slides nicely into the terminal. There's the inside of the terminal, and it makes flat to flat surface contact. Low resistance, good quality connection, right the first time. Isn't that the whole point of EX? EX is an increased quality management system compared to industrial. The equipment's increased quality. The work is supposed to be increased quality. And there's your dual bootlace. Slides in nice and easy. Now, if anybody says, well, we don't have the proper size ferrule for it, let me show you a 200 mil ferrule. I have it in my hand right now. So, North America. Ooh, let's ask you a first question. Do you use wire nuts, barrettes, the twist-on connectors in your installations? Now, you don't have to be in North America to run into these. Yeah, you could have manufacturers that build things in Canada, Mexico, America, maybe even South America, and they ship these overseas. I can tell you what we do with them in Australia: cut them off. And in Europe, cut them off. And most Asian countries, cut them off. 45% voted. Apologies if everybody can't vote. Okay, we'll share. So 14% of you use these or have used these. Now, you have to consider that North American standards to, like, let's say AEX, American EX, they are kind of called for. We'll talk about it. For those who are in your full screen, press escape, and this will bring you back to the smaller screen and allow you to vote. So I think we shared that. So 14% said they had used it. Apologies for it being difficult. This is the first time. Now, but what problems do we have? So wire nuts, bare strands. Also, this is a worldwide issue where you have fraying of your individual conductors. And what about ambient temps? Is there room for improvement? Certainly. So what do we have? Well, we received a light from North America that was meant to be ATEX, IECEx, and everything. These internal connectors down here on the bottom right are not rated for hazardous areas. Also, it was only rated to 40 degrees ambient temperature, but the equipment was rated for going to 65 degrees ambient temperature. Problem there, those are no good worldwide. North America, meh, open to interpretation. Terminals, well, you can see all the copper on the strands. So reduce creepage and clearance distances. Now somebody might say, well, it meets the 6 millimeters. Over time, heating, hot, cold, contracting, it will move. It's not a good termination. We have the tools. We have the ferrules to do this. Now, what about this one, the one in the top center? This is a typical North American technique. I know because that's where I came from. Even if this is not EX, it's a poor way of doing terminations. Now, what's the problem? The exposed strands, for one, and two, the terminal types, how the post goes down where it doesn't have a flat surface evenly distributing pressure, is quite poor. So what could they do? Different terminal types and use ferrules. It would increase the quality of your terminations, lessen chance of failures. But what's the problem with wire nuts? They damage, well, your wires. So if it's your connection means and you're using a wire nut, is the wire nut EX rated? You know, all terminals need to be EX rated inside of EXE. So if you're to use a wire nut inside of EXE, please, somebody tell me where an EXE wire nut exists. It does not. So it actually calls into, for low temperature, there's low temperature tests to be done. These terminations will not pass. Now, in the American one, where ambient temperature range is not marked, where it says EX, it has to be rated from -20 to 40 degrees. Well, these ones on the bottom right, the wire nuts, not EX rated. And if the product's marked for class 1, class 2, or class 3, division 1 or 2, well, once again, they're not rated for that. And it says the ambient temperature range of -50 to 40 degrees Celsius. So once again, they're really not good for most installations. And they're not marked for hazardous areas. So why are they used? There's rooms for improvement, let's put it that way. When we talk about frame, this is why in North America, I remember we used sometimes Ferrules for instrumentation, but for power, it wasn't done. We had a few times where we had fraying going on, and what happened was we tripped a breaker or we blew a fuse. It is unsafe completely. I certainly would not use the insulated pin locks. Heat tracing. I'm not going to go too depth into this one, but a certain manufacturer calls for the terminations to be in an EXE kit, but somehow it ends up not being that way in the field, whether it be tube trace bundle or regular heat trace. In Australia, they didn't use these instrument huts. It would have been a very good idea. Perfect way to terminate these terminations. All terminations shall be an ATEX type enclosure. This little boot is not an EX enclosure. That's what he says. But right here, this is heat trace that was terminated together or repaired with cable tape. Super 33, 3M Super 33. So that's going to melt, possibly catch on fire. Remember what I told you about the transformer? This is the other side of it. So what happened? Well, there was torque marks on the bolts, but then somebody took the bolts off, and this thing ran for a few months. It blew up because they ran it with 1 of 8 bolts on the bus link inside the transformer. So that top section that you see that is burned, that's the modular bus duct, the EXM bus duct. So when you do things incorrectly, you would think that you could just replace the bus links. You cannot. That EXM bus duct, remember, is concrete. So the entire section, whether it be 30 meters or 1 kilometer, you're looking at replacing it all. So millions of dollars, perhaps. Now, another question. Do any of you use bare strands on your site? Like, do you install it without anything? Not just pin crimp, but not pin crimp, not a lug, not a ferrule, not a bootlace. %47 voted. Once again, I'm sorry if you guys can't vote. Somebody's saying voting's only available in window viewing. So some people may on their phones, so apologies if you cannot vote. But you will see this in the video afterwards. Okay, that's okay if you can't vote. Apologies. So 18% of you said you use stranded bare strands. Now, I would hope that would only be for big conductors, but if that's for small conductors, that goes against the standards. Yeah, I think I showed you the exact clauses from the standards. So if you're an installer, an inspector, obviously you can't go pushing your EPC or end user, or they're on a higher level. But what you can do is you can ask the questions and you can show this presentation. Feel free to do that. Now, I'm going to try showing you guys a video. Hopefully it'll work. Okay. So this is going to show you how to do a core end sleeve, a bootlace ferrule. Apologies. Okay. Hopefully that gives you guys an idea. Now what I'm going to show you is, have you considered torquing standard? So if you were to compare how you do torquing, if you're not using a torque screwdriver or a torque wrench, are you doing a quality installation? Certainly not. If these tools that you see on the screen here were utilized, not everybody uses them. They're great tools, but they're expensive. So a torque screwdriver, not every technician has to have them. You can implement into your quality management system where the lead or the one QA/QC guy goes through and checks for tightness of all terminals using that tool. Now, for EXD boxes or for your bolts within an EXE motor or DE motor or D motor, if you're not using a torque wrench, well, I could show you pictures of broken studs. Yeah. So without properly torquing devices, torque screwdriver or torque wrench that are properly calibrated, how can you ensure you're doing good quality work? A good way to reduce the number of faults, the number of reworks, is to have a good quality management system where procedures and work method statements are called for with a decent quality tool. You don't have to go for top of the range. Now, when somebody says the correct tool for the task, now tools are provided by some manufacturers and other ones are not. So when you're in a country in North Africa or Central Asia, the gentlemen do not bring their own tools, probably. On some union jobs in North America, you cannot bring anything besides the tool list. In other ones, the manufacturer, the EPC provides them during construction, and you sign them out every day. But if any end users or EPCs are paying attention, there is very good use for these tools. Now, somebody says very difficult to use tools on site in case of maintenance. Well, the thing is you can get the, analog version without a digital screen. So if that's your worry, you can get a torque wrench without a screen. That's not a problem. The screwdriver is not battery powered. So you can get the torque wrenches that you need. So your terminals won't be too tight. You won't damage any cores. They won't be too loose. Your studs won't break, whether it's a high voltage stud or a motor stud. Because when a stud breaks, that motor is no good until you repair it. That can be a very expensive cost, yeah? So cost of calibration and tool is less than a short and equipment failure. So if the motor fails because the stud was too tight and as a hot, cold, and it breaks, that motor could be down for weeks. The use of a torque wrench guarantees that you don't go too tight or too loose. If it's too loose, you could have a line-to-line short. It could build up resistance, build up carbons, arcing, sparking. It could cause an explosion. If you don't properly torque your studs, terminations, terminals, you can cause a potential source of ignition. So to say that you can't use these because of cost, you're costing yourself lots of money. Okay, let me back this out for you guys. Go back to that. Okay, so I'll answer anybody and everybody's questions. Can you guys see the thank you screen? Is that where we're at? Okay, let me just go back and answer some of the questions that some people asked. It's all about the correct tool use. Yep. But just remember, selecting the correct tool is not just the requirement of the technician or inspector. Their supervisor and the responsible person on site, management, is responsible for that as well. If a worker causes an explosion, an injury, a death, who's at fault? Well, the person that did it, but also the end user takes all responsibility. They take the financial hit, they take the reputational hit, and perhaps they go out of business and everybody loses their job. Everybody's involved. It's not just one person's responsibility. We need to remove this siloing in our industry of that's not my role. Everybody has to be competent. Competency changes from day to day. You could have a bad day today and you may forget to do something. Can you discuss a bit on ribbons used on marking plates? Basically, they have to be part of the design. They have to maintain the IP rating. If you make a modification, let's say you have a Stahl junction box and it comes with their little seal. If somebody changes it, well, that goes against Stahl's certificate and their IOMs. So if water gets in, you're out of luck. They will not cover you for any warranties because a modification has been done that went against the certificate and IOMs. Torque wrenches must be calibrated regularly. Correct. Probably every 6 months. But if they're banged and used a lot, maybe 3 months, maybe 1 month. Standard practice of terminating cores of cables running hazardous to non-hazardous. Well, the requirement as per the standard is terminate all spare cores on all ends. Yeah, but earth it only at the non-hazardous area end. Yeah, but if it's an instrument, hopefully you don't have any spare cores in the instrument. If you do, heat shrink and your shield drain, leave it floating and insulated. Do not terminate a shield drain wire, your drain wire, at the instrument end 99.9% of the time. There may be other designs, be aware of that, but the whole point is to drain away interference. Yeah, you can, an instrument operates at 4 to 20 milliamps. If you have any interference, you can operate a shutdown valve due to induction. And you don't want to operate that unless it's meant to. Is this available via video? Yes, it will be on YouTube. We will share that. The technician needs to know and understand how to use the tools. Well, the end user and the EPC have to do verification of competency. It's not just the responsibility of the technician or inspector to know how to use the tools. It's the responsibility of their company to ensure they know how to use the tools. And if they don't, they shall be sufficiently trained and hopefully achieve competency. Responsible persons have no idea what correct tools are used as they may have never done anything practical. I'm being diplomatic, but I'm nodding my head. This is the problem that we have between engineers and field people, or manufacturers and EPCs, or manufacturers and end users. The reason we are doing these webinars is so that people can see what happens if you don't do things correctly, and also see directly what the standard says, because somebody can read the same sentence, all 100 of us can read the same sentence, and we can all have a different opinion. Now, with clear, keep it simple, silly, and memes that we've shown in this presentation, I hope everything is much more clear for you. What about crimping of solid non-stranded conductors? In North America, they don't do it. In the rest of the world, it can be done, but it's rare that even a solid conductor is chosen. More think of a thermocouple. So for a thermocouple, the wires actually have to overlay each other. You really should not have two separate terminals. You should have a tunnel terminal where they overlay each other and make perfect connection. Because if you have any resistance, obviously you'll have a differing temperature value that's incorrect. For terminating thermocouple extension, the calculations are based on MV loss, which may be introduced by Bootlace crimps. Are we able to use crimping with thermocouples? No. Tunnel terminals, have them overlapping with each other and crimp them down with the terminal only, not a ferrule, so that you get the perfect connection. If customer recommends insulated pin lugs, can we decline the request? You could be putting your job at risk. What I would do is show them this webinar. Show them the screenshots directly from the standard. It only calls for ferrules and core end sleeves. Insulated pin lugs are not core end sleeves or ferrules. The definitions are there. Anybody can Google it. Yeah, somebody mentioned the certain heat tracing one. Yeah, I'm not going to get into that one. That's another session. I'll send you a picture of over-earthing from an installation. Yeah, there's some installations where people go overboard on earthing. The earth tags, are they needed? If you have a metallic box or you have a GRP plastic box with metal threads and metal backplate with metal glands and an internal external earth stud, hey, that's the easiest solution. But EPCs go, well, that's too expensive. But they do not consider the installation time by personnel. The installation time to install a earth tag is a lot of wasted time. It's not needed. HVAC is my favorite, somebody said, for terminations. Yeah, because you could be looking at EXD, P, I, E, oh, lots. If EXE terminal box does necessarily, must you use ferrules instead of insulated pin crimps? I showed you the standard. It clearly defines that. So this one with all the highlighted sections, it'll show up on my screen. There you go. 4.2.1. That is 60079-7. Mentions the word ferrule and core end sleeve and the conductor not being damaged, the conductor insulation not being damaged, and the insulation of the ferrule not being damaged. Well, everything I just said, the insulated pin crimp does damage those things. So people can disagree, but it's clearly defined in the standards. It's just that people usually don't want to read. There's a lot to read there. In the case of double wire inside of bootlace ferrule and single terminal, does this typical installation affect the temperature rise calculations for the number of terminals? Well, yeah, you have to tell the manufacturer, yeah, how many wires you plan to use. So if you were asking Stahl or Eaton, these would be part of your information you would give them that they would then do their temperature calculations. Can you explain about twin lug types? So bottom right-hand corner here, let's see if I'll make the, hopefully you guys can see this. So basically you must use two wires of the same, two cores of the same size. You pre-twist them clockwise, put them through and crimp it. If you have any excess out the end there, I should have snipped a little bit off. Is it accepted to use insulated end caps for unused cables which are selected with suitable voltages? So I think what you're asking about is inside of it fluorescent lighting. Sometimes you do have like a clear kind of end cap that comes from the manufacturer. That's okay. Okay, that's part of the design. It's been tested and certified. No crimping of solid cores unless soldered and crimp is designed for soldering. That's one comment from somebody, but basically, yeah, solids, usually 99% of the time, no, you don't crimp it. What is the meaning of termination? What is the main reason for termination? The meaning of termination is the connecting of these two cores or two bus bars, or yeah, a termination is you're terminating, connecting something together. What is the main reason for termination? Because we can't run always one cable the entire length. Yeah, we can't just have a fly lead, but you're always going to have a termination anyways. It's to get a good connection, to reduce the resistance, to reduce the heat, to not have any voltage loss, you know, I2R losses due to heat, yeah. Not have any increase in current. Can you discuss the rivet? 1 second, guys. Just need to find where we're at. What are your thoughts on WAGO connectors? Well, certain WAGO terminals are very good. Certain WAGO connectors are very good. I'm sure there was some picture somewhere. Once again, I'm not here to throw any company under the bus, but some connectors, terminations cannot be used in hazardous areas in the IECEx ATEX world, or EACEx, or in Metro. North America, they are still updating their standards. By the way, they update their standards every 3 years for any NFPA NEC 70 and for CEC Canadian Electrical Code Part 1. Is it acceptable to use insulated end cap? Okay, we already asked that question. Somebody mentioned heat tracing. It's a contentious issue. Yes. Twisting the wire in a ferrule is not allowed. You pre-twist the wires. Yeah. Some manufacturers call for it, some do not. What you can do is when you pre-twist the wire, it ensures that none of it goes off and frays. But once again, always read the certificate, the IOMs, and the standard. Problem is not all of you have the standard, or the IOMs, or any of these things. So if you have any questions, feel free to ask. We're here. Second. How to connect 3 cables in 1 terminal? Well, get a dual layer terminal, or have 2 terminals. You could have a dual bootlace in one, and you could have a single in the other, and use a bridging comb. Is it necessary to terminate the unused cores in a combination control EXDE boxes? So if you're talking about like an EXDE control panel, yes, all unused cores, as per the standard, shall be terminated and earthed back at the non-hazardous area end. Is shield of a signal cable, so basically instrumentation, considered an unused core? Well, it has a purpose and it must be terminated. Usually 99% of the time, I keep your shield drains isolated from all other earths and all other structural metal and the gland all the way back to its source of supply and terminate it to the instrument earth bar. Okay, the intrinsically safe earth bar, or the FE, which is your instrument earth. So you could have instrument shield drain earths, or you could have intrinsically safe earths. You have to keep those isolated from each other. And if you have individual shielding and overall shielding, or multiple pairs or multiple tries, you have to keep those all isolated from each other all the way back to their source. Okay? At the instrument end, you should leave that floating. Usually a clear heat shrink is a good idea. Can it be terminated using end cap heat shrink? So your shield drain, yeah, when you do your cable breakout past the gland, you would have an overall heat shrink. Before you shrink it, you would slide that clear heat shrink, which is longer than the shield drain length, and you would heat shrink that overall, so that would hold that into place. What potential issues can you have from heat shrink cable termination kits? Well, if you use heat shrink instead of a terminal, it can degrade over time and it could touch the side of something, or when somebody's opening and closing an instrument cover, they could catch it between the threads, yeah, and you could cause a line-to-line short, even on a motor, yeah. Is it allowed to cut off the extra copper strands from the end of the bootlace? My personal way of doing it is I make the strands go further so that you make sure you have 100% coverage within the crimped area. And then, yeah, use a small set of sharp side cutters and cut it down, because sometimes ferrules are too long. You can cut them down depending on the terminal type. Not all terminals have the same terminal depth into them. For every terminal group is in single box, earthing is required. I'm not sure what you mean. Your shield drains, every single one of them have to be isolated in an isolated terminal. Usually people use a specifically black and yellow one, or it depends on the manufacturer of the terminal. Earth your cables. Continue your earths all the way back to the safe area, back to the substation, back to the LER, the LIR, whatever you call it. Take it back outside of the hazardous area, back to where the main earth bars are, the protective earthing earth bar, the functional earthing / instrument, and your intrinsically safe earthing points. Usually they have their own ground rods outside. Sometimes they have a shared connection at the protective earth bar, and then they go out finally that way. It depends on what type of earthing system it is. Okay. Is there any more questions, or I'll give it another 30 seconds. So just showing people some insulated pin crimps, how take a look at that. They really don't go nicely into terminals. Their surface area, once again, is half that of a ferrule. Okay, I'd like to thank everybody for attending. Oh, one more. Speaking of IS sleeve earth, I see some EPCs allow black sleeve instead of yellow-green. Is this okay? Contentious. It really should be green, green, or yellow. But you may have national deviations. So ideally, what you would have for your PE earthing is green, yellow all the way. And your functional earthing, you would have yellow. And your intrinsically safe, you would have green. But sometimes people maybe mix the green and the yellow between the FE and the ISE. Can we get a copy of the presentation in PDF? No, but you can watch this on YouTube at any time. And should you need any services, we are here to help anybody and everybody. So once again, thank you everybody for attending. If you would like to contact us, please see the contact information there, info@ind-ex.ae. Can also reach me on WhatsApp at any time. Thank you very much for your time. 55 stuck around out of 100, not bad. People have different interest points throughout the presentation. It changes from time to time. Thank you very much.